everyone, and welcome back. In a previous video, we went over an application of a stack which was reversing the chars in a string. You can see here the output of pushing hello, each character of it, onto the stack, and then popping each character out of the stack, producing this output which is hello in reverse. So we covered that example, at least pictorially, in a previous video. In another previous video, we implemented the stack ADT, the abstract data type for a stack, using a linked list. So you can see here in a stack.h file, I've got a stack class that inherits from a linked list class. So let me show you that linked list class, which we also coded up in a few previous videos. So the linked list class has a node struct which stores an integer value and a pointer to the next node in the list. So what I want to do in this video is essentially use this implementation of a stack in order to code up this reversing characters in a string problem. All right, so I'm going to head over to main.cpp and I'm going to comment out all of this code here from our previous video where we were exercising our stack. We were pretty confident that it was working, so now let's do an actual application of using our stack. So it's going to be okay to push and pop chars with our stack, and the reason why is because each node in the linked list stores an integer. And so what really is a char? Well, a char is a 1-byte integer, and for storing an actual character, like maybe the lowercase h or the uppercase a or something, what's really stored in that char is the ASCII value for that letter or for that character. So for example, the ASCII value for uppercase A, this guy right here, is ASCII value 65. So if we were to push A onto our stack, then value 65 would be stored in a new node in its value attribute or its value member. So we'll have no problem just pushing each character of a string onto the stack. When we pop the stack, we're going to get an integer, so we should static cast that to a char before we print it out. All right, so let's declare a string. I'll call it something like to reverse. It'll store hello. Then I'm simply going to iterate over each char in to reverse and push it onto this stack here that I declared on line number 5. So it's going to push the integer representation of this char, which will just be the ASCII values for these characters. All right, just for fun, let's see out and see what the size of the stack is. At this point in the code, it should be 5 because each one of these characters in hello will have been pushed onto the stack. All right, then I'm going to have a while loop, and while the stack is not empty, I'm going to pop off the element, the char, the integer that's on top of the stack. So I'm going to actually declare another value here. I'll call it int ASCII value. Okay, so ASCII value is going to be used to store what's popped off of the stack. And then I will see out a char representation of ASCII value. So ASCII value is an int, but I want to print it as a char. So I'm going to just cast it into a char. Okay, I'm not going to put an endl on here because I want all of my chars to be jammed right next to each other so it looks like a string, but then I'll print out an endl outside of the loop in order to mark the end of that line. All right, so let me compile this and make sure that I have all my parens there. All right, so I run this and you can see my output right here. For hello, I get OLLEH, which does in fact match my output here. In fact, I could even put a little label on this here. so it's more easy to find because we're going to test this with a few other strings. All right, so let's try maybe capital H, hello, see how it looks. And there it is in reverse. And we're also seeing right before the output the size coming from line 18 being 5 characters or 5 nodes in our linked list, 1 for each character. So let me try something a little bit more advanced. Let's do stack ADTs are, let's do awesome, and we'll get some punctuation characters in there too. And there it is in reverse. All right, so there is an example of an application of a stack. Something kind of fun to think about is what's the time complexity of our algorithm here for reversing a string? Well, here we're iterating over each char in the string to push it on the stack. Okay, pushing is is constant time complexity because we don't have to traverse the linked list. So this here is n operations, and then here where we pop the stack, we have to pop it n times because n items were pushed. So this is n, so really this is n plus n, which is 2n. So our growth rate is about 2n, which means our order, our time complexity, would be big O of n. However, as you probably anticipated, you could probably write string reversal that's much more efficient than growth rate function of 2n. So that would be a fun challenge to try out if you haven't done so already. I'm not claiming that this is an efficient implementation of reversing a string, but it is kind of a fun one using our stack. All right, that's it for our last in, first out application using stacks. Thanks for watching.